Hi, today we're going to cover powers and exponents. Our goal for today is to evaluate expressions containing exponents. So let's first of all talk about the word power. Power is an expression with an exponent and a base. That's it. So let's give you an example. Here we have 3 to the second power. Some of you guys might know it as 3 squared or 3 to the power of 2. Either one is fine. So, the 3 here, which is in blue, that's the base. The 2, which is that smaller number, that's the exponent. Now, when you see 3 to the power of 2, that basically means 3, which is the base, is going to be the factor 2 times of that. So, you're going to see this written as 3, 3, and multiplied together. So if you see 3 to the third power, it would be 3 times 3 times 3. And again, you are multiplying, so this is 3 times 3, which gives you 9. Alright, so the first thing that we're going to talk about today is we're going to use exponents and powers and model it using geometry. So a lot of times you hear the word squared and cubed and kind of figure out where that may have come from. Well, that has a little something to do with the geometry. So let's have a look here. Here we have a square. I know it's not perfect. Sue me. Here you have 4. 4, that's the length of the size of that. So if you look at this, if you wanted to go ahead and model that using exponents and powers, you'd say that's 4 times 4. And if you notice 4 times 4, well, they're both the same, so that means you can write it as 4 to the second power. And in this case, that would be called 4 squared. That's where that little number 2 comes from. Okay? Now let's look at something that's more three-dimensional, 3D shaped. I know that's still kind of flat because it's written on a flat board, but if you look at this particular shape, you have 3 dimensions. You have your length, your width, and your height. So here you have 2 times 2 times 2. If I were to write it out, 2 times 2 times 2, that's 2 to the third power. Okay? And then you have right here a hexagon, so 6 sides, they all have 5, 5, 5, 5, 5. One more. 1, 2, 3, 4, 5, 6. So this would be written out as 5 to the 6th power. And again, you can also, switch them around, vice versa. If you were to go ahead and take 5 to the 6th power and rewrite it out, it would look like this on the top. Same for these other 2. Now, what happens if you have a box and you don't know what the measurements of the sides are? Well, you can just use the same method that you see here, but instead of having instead of having 2's, you can use x's. Well, this would also be an x, because you don't know what they are. And since that's a square or a cube, they're all the same. X times x is equal to x to the third power. Alright, let's go ahead and get into evaluating powers. So here we have 5 to the second power. That means 5 times 5. That base is your 2 factors because of that power. So that 2 tells you have 5 of these, 2 of these. So it's 5 times 5, that gives you 25. Now the same goes when you have negatives. The 2 tells you that you have, in parentheses, whatever's inside will be that number multiplied by itself. So here you're going to have negative 5 in parentheses times negative 5. So negative 5 times negative 5, and going back to your rules of multiplication and division, negative times a negative gives you a positive, and that gives me 25. Yes, they're similar, but this one is, you need to understand that there is a negative. Now, this and this looks very much the same. The only thing that separates this and this is the parentheses. Now this is something special, so I need you to make sure that you pay attention to this one. Okay? So this actually means 5 times 5, because that 5 has that 2 power. It's not in parentheses, which means that negative doesn't go with this 5. So then now you're just going to go ahead and place that negative. Alright, now look at the fraction. This same deal here. You have 2/3 to the third power. 3 means you're going to go and write this 3 times and multiply them as factors. 2/3 times 2/3 times 2/3. Multiply it out. 2 times 2 times 2, that's going to give you 8. 3 times 3 times 3, that's going to give you 27. Now, if we have something like this is called writing towers. So what you're going to do here is you're going to go ahead and look at this. This is actually your answer. So let's go and write this down. This is actually what they want, the answer. But they want you to show off this answer using this with a base 9. So I want you to think about this. If I have a base of 9, so let's write my base of 9. I want this to have an exponent that'll give me 81 as an answer. That's what this entire thing means. This means I want 81 as an answer, and 9 is my base. So the number that you're going to have here is what times, well, 9 times however many 9s is going to give me 81. And 9 times itself, which means 9 times 9 is 81, so that's going to give me a power of 2. Alright, let's have a look at this one. So here we have a base of -4. So let's go and just draw that base right now. So you have -4. And again, that's our answer. So we want the answer of -64. So we need to ask ourselves, -4 times -4 times -4 times -4, however many -4s it takes, will that give me a -64? And so you can just kind of test it out. -4 times -4, that only gives me 16. Now, if that's 16, if I multiply it by another -4, well, 16 times 4 is 24. I'm sorry, 64. So if I take a negative times a negative times a positive, that will give me my -64. And just count 1, 2, 3. So this is going to give me a power of 3. Alright, our last one is a word problem. Sam wants to predict the number of hits she will get on her YouTube channel. She received 3 hits the first week. If the number triples every week, how many hits will she get on the 5th week? So this is an exponent and powers question, just written in a word problem format. So now we can go ahead and go one of 2 ways. Let's go ahead and actually do this out. So if she does week number 1, she gets 3. So this is our week. Week number 2, remember it triples that. So that would be 3 times 3, which is equal to 27. Our 3rd week would be 3 times 3 times 3. So it triples that, and that gives me 81. Oops, sorry. Jumped the gun here. 3 times 3 is 9. 3 times 3 times 3 is 27. 4th week would be 3 times 3 times 3 times 3, and that gives me 81. And then finally, on the 5th week, 3 times 3 times 3 times 3 times 3 is going to give me 243. Now, a much easier way to do this, well, we know that there's going to be 5 weeks that we're tripling. So we're actually taking 3 and doing that 5 times, multiplying by itself 5 times. So the easiest way to do this, 3, 1, 2, 3, 4, 5, 3 to the 5th power, and that's going to give us 243.